Hey there everyone, how's it going? This is Jake, community developer here at Oraculi, and today's Tuesday. And on Tuesdays, we usually bring cloud cost savings tips. And this is something that I'm really happy that I'm able to do because there's just so many good resources, there's good articles, videos, and documentation out there that people share openly to save costs when it comes to cloud. So there's a lot of optimization to be done out there, and with these videos I want to be able to go through, scour the internet, and distill cost recommendation tips around certain topics each week. And this week we're going to be talking about Amazon API Gateway. We're going to be leveraging two articles that I found that were very, very interesting. One is going to give us a series of tips, and the other one is a use case when it comes to reducing data transfer output, which is quite useful for organizations that have a high number of HTTP requests hitting your API gateway. And how do you know if your application is under a particularly high load of requests? Well, you can check that here, for example, in the Komiser dashboard. I'm looking at the network tab. So here we can see the absolute amount of API gateway requests that have come in the last 6 months. We can also see an aggregated view of the amount of APIs that we have, both REST and HTTP, today's incoming requests. So this is a good place to start to have an idea around how many requests you are working with, since it is one of the big pillars of that you'll be charged on when it comes to API Gateway. But let's quickly jump into those two articles that I mentioned beforehand. The first one is an article produced by Storm IT. They first go into a bit of an introduction of API Gateway and the free tier. They also talk about the differences between HTTP APIs, REST APIs, and WebSocket APIs. They touch on the API Gateway cache pricing. But we're just going to go straight into the cost optimization tips. The first one has to do with choosing the right API gateway. So this is mainly, in most cases, going to be a decision between REST APIs and HTTP APIs. Unless you have a very strong reason or you need to use some of the more advanced features that come with the REST API, my recommendation would always be to try to fit your application inside the HTTP API features, because it's close to 70% cheaper than the REST API. Also consider, instead of API Gateway communicating with Lambda functions and those Lambda functions performing as middlemen, you can leverage the API Gateway integration feature, which can integrate directly with AWS managed services like Kinesis, DynamoDB, SQS, and SNS, and therefore you can circumvent the need to use some sort of logic in the form of a Lambda function, and you can send your requests directly from the API Gateway all the way to your destination. Authentication that comes with API Gateway is a little bit costly. Maybe consider using Cognito authentication, and this is if your front end is the only consumer of the backend API. It seems a little bit drastic, but maybe it might be worth considering as your application scales to fully swap out API Gateway for an application load balancer, seeing as the application load balancer supports triggering of Lambda functions. And in case you really do need some of the advanced API Gateway features, the application load balancer might do the job you need. Number 5 seems a little bit obvious, but it is worth going through, making sure that you don't have any unnecessary or redundant API calls. And moving on to number 6, which is to reduce data transfer costs, which comes from DTO, data transfer out. There's a few ways that we can go about reducing this. One way is to leverage CloudFront, in which we'll move our most accessed and relevant data to users to the front of our AWS network, and giving our users quicker access and just more of a smooth experience when using our application. And data transfer from other resources like S3 and API Gateway to CloudFront is free. So of course, when the application that we're using serves very few requests, reducing the data transfer output probably won't make that much of a difference, but it really, really begins to add up when we talk about applications that serve millions and billions of requests per month. And since you might have an application that serves millions or billions requests per month, I think it's interesting to have a look at this following use case to see what they did to reduce their DTO. Okay, so let's head over to the second article. So this is an article written by Games Analytics, and it's a games company that has a games events API that serves around 1.2 billion monthly players and nearly 90,000 games. So the amount of monthly requests is absolutely astronomical. And when they were going through their cost reduction efforts, they saw that the biggest amount of cost came from their data transfer out. And they took a series of steps to reduce that data transfer out. This is what they found. In order to be able to reduce the cost, they needed to know where the data transfer out was coming from. And then they realized it came from the HTTP responses to the requests that were coming in. It was also coming from the TLS handshake that would happen to establish the HTTP sessions. So in order to reduce it, they did three things. The first thing is that they went to look at their original HTTP response and the series of headers that made up that response. And they saw that the header was 333 bytes and it could actually be reduced. And they reduced the following headers. These two, access control allow methods and access control allow headers, were only required in pre-flight requests using the option method. So since this was a post method, this could be reduced. They realized too that each line break, it's a CRLF or a carriage return or line feed. And these are control characters or byte code that can be used to mark a line break. And those come with a byte cost there. They saw that the header XGA service was a header used in the past for debugging, but they didn't need it anymore. And they also managed to reduce the access control allow origin headers in some cases, because it's only required when the request is a CORS request. And this can be determined by checking for the origin request header. But if that header was not there, then this header was not required in the response, which resulted in the majority of the responses to be reduced down to 109 bytes. This was a reduction of close to 2/3 of the DTO that they calculated, but they only saw a reduction of 12% in the cost. And then they realized that there was a certain amount of cost that came with the exchange of the bytes during the TLS handshake. So the TLS handshake is a process that takes place to establish the HTTP connection between the client and the server. They intercepted the HTTP handshake process, and they saw that the total amount of bytes exchanged were 5,433, and close to 5,000 of those were the certificate. So the second thing that they did is to try to leverage further the TLS session resumption, which has to do with resuming previously established connections and not having to create so many connections, because with that connection creation, of course, we have that data transfer. And the only way that they were able to actually do this, the only lever that they found to be able to change the TLS session resumption, was to actually increase the default setting for idle connections from 60 seconds to 10 minutes. They saw an increase of the utilization of the TLS session resumption by changing this default setting. The third thing that they did was to realize that the heaviest element in the TLS handshake payload was the certificate itself. At the time, they were using an Amazon Certificate Manager issued certificate, which was 4,980 bytes. So what they ended up doing was buying another certificate on DigiCert, and the total amount of the certificate payload turned out to be 2,767, which resulted in a huge reduction. So with these three actions, Games analytics were able to greatly reduce the amount of cost related to their data transfer output. If you are part of an organization that has a very request heavy application, I would definitely recommend for you to go through these steps too, to find where you might be able to save some cost. The actual article also at the bottom has some other very interesting cost reduction tips, and I would definitely recommend for you to check those out. All in all, this is it for this week. Thanks a million for watching, and I hope this was informative. All the best. Bye-bye.